Welcome to our webinar. We have an awesome panel here. My name is Karsten Samaschke. I directly hand over to Archis Gore from Polyverse, who is going to do the introductory round. Yeah, Archis, welcome to the webinar.
Yes, thank you for having me. Do you want me to share the slides that we made, or what do you want to do?
Awesome. Do that. Do that.
Okay.
You should have the permission to do that.
Yes.
My permission is always given.
Yes. Okay. You betcha.
Perhaps while you are trying to share something, let's do a little framing. Today we are going to talk about security. We are going to talk about cloud native security to some extent. We are going to talk about security with Kubernetes, holistic approaches, and what Polyverse brings to the game there, and what we as Cloudical bring to the game with VanillaStack, and how all of those things belong together and basically add up to each other. So, Archis, timing, perfect.
Perfect timing, huh?
Awesome.
Hi, I'm Archis. I'm the CTO here at Polyverse. Just a quick overview of who we are and why we, why we love Cloudical, but we love Jurlind a lot. And he's just hearing me say that for the first time today. And that is because he has a PhD in usable security, and so it's a match made in heaven. What we really do, just at a high level, is we focus on making security tractable and usable. It's not just about about complicated words and keywords and whatever. It's about how can this benefit people, especially developers, and how can security people bring security to non-security focused people. This is our agenda today. We're in the middle of our introductions. And then I'm just going to pass this back to Karsten and Jurlind for an introduction about VanillaStack. Then I'll go into, like the holistic approach to security. We'll demo the polymorphing, and then I'm going to show a little hacker demo. And then, yeah, and then we'll take questions. Back to you.
Well, thank you, Archis. I take over now because, that picture. I'm too old for that. Well, that basically got me off the shelf now. So I take over for a second, and I'm going to now share my screen. Because I want to give you some insights into VanillaStack. I don't want to make that too long. I don't want to make that too complex, but just to give you the rough idea of what we are talking about here, at least from a overall perspective. Well, first of all, currently, we have a lot of pressure on us globally because as people and operational teams working within the cloud environments or within any kind of environment at the moment, we are faced with a lot of challenges and expectations, right? Flexibility, deployments, reactions, everything should be done faster, everything should be done better, 24/7 automation, governance, and all of that at lower costs. That's basically the point where it gets ridiculous unless you change something. And that changing is basically doing cloud. Doing cloud ultimately implies that you set up new environments, and most of the people that go into cloud environments start that by doing lift and shift approaches. They tend to replace and rebuild their existing data centers, their existing solutions within the cloud environment. Awesome idea. Gives you a jump start. Not speaking of security issues because we have two experts on that, but gives you a jump start in that. But problem is, if you just do lift and shift, you might be able to, I don't know, save like 15–20% of your costs, and you might be able to accelerate a little bit, but you need to change things way more fundamental to actually leverage all the advantages of cloud environments. So The next step, the logical next step, is then switching over to containers, because containers, well, it's a buzzword nowadays. It's a hype thing, but they tend and they promise to solve a lot of problems. But frankly, when you switch over to containers, you might become a little bit more agile. You might become a little bit more effective and efficient. But then again, the administrator, the ops guy that in the past had to handle like 10 servers, now has to handle like 1,000 containers at the same time. What could possibly go wrong? You need to have some sort of infrastructure in place there, and that is typically now understood to be Kubernetes, which is a container orchestrator, self-healing service, and automatic load management are provided by Kubernetes. Kubernetes per se is secure, or quite secure, let me put it that way. Our security experts here in that webinar might have a little different view on things, but as a platform, it is quite secure. It's 100% open source, and there's a huge and ever-growing community around it. In fact, Kubernetes is understood as a true game changer, because 76% of all organizations plan to go cloud native using container and Kubernetes technologies over the next 3 years. That is the outcome of a study conducted by 451 Research Group just like 3 months ago. But truth to be said, and that basically then again already starts paving the path towards what we are going to talk about more in detail later on. If you just happen to switch over to Kubernetes, well, you are exchanging one kind of challenge with another kind of challenge. And challenges are always a bad thing, because with Kubernetes, you have a steep learning curve. Jurlind already nodded upon that when we talked about that upfront steep learning curve always implies a huge and ever-growing room for mistakes and errors. You have to do a lot of integrational work. Your applications need to be rewritten. You need to have infrastructure deployment automation in place. And you quite often do not have luxury to basically say, okay, I just do one thing, containers, and not the other thing, VMs. Typically, the default installations are not production ready, and quite often the solutions are vendor locked. And that leads us to the point where we are talking about VanillaStack, and basically the platform that is giving us the platform for our today's discussion. VanillaStack, I don't want to bother you with too much of marketing blah blah at the moment, but VanillaStack is basically an enterprise open source cloud stack, and we, Cloudical, as the makers of VanillaStack, we understand Kubernetes as an operating system. We do know it is not, but from our perspective, a truly cloud-based environment ecosystem starts with Kubernetes and not with the underlying Linux as basically the foundation. Not to be understood as Linux is not important, not at all. Linux is the cornerstone of what we do there. But what we want to achieve is that you are able to bring your own Linux, that you are able to use whatever you want to use. And Linux to us is more like a driver in our open source cloud ecosystem. You can't do without. And if your driver is wrongly and poorly configured, well, enjoy. Jurlind and Archis are going to touch on that later on. So yeah, you better take care on that. VanillaStack provides you with full commercial support, and it's 100% open source. We always try to use the vanilla editions of projects. We give support for the community. We get support by the community. And to us, pretty importantly, we don't impose any kind of vendor lock on our customers, because you can use the Linux that you want to use. You can use the tools that you want to use. VanillaStack is a complete stack. I don't go and touch on everything here, but basically you find something for every kind of approach and every kind of workload and task you have to work with, like a obviously Kubernetes platform. You find something for your infrastructure of automation like OpenStack and KubeVirt, for your workload automation like Cloud Foundry, GitLab or Jenkins. And we include a lot of operational and security related tools. Jurlind is going to touch on that a little later, because we do that for a purpose and a reason, and that is always providing a production grade environment. Importantly, it runs on nearly any kind of Linux. So we are happy to have VanillaStack being able to run on Fedora, CentOS, Red Hat, OpenSUSE or SUSE Linux, Debian, or Ubuntu-based systems. Again, don't want to bother you too much with all the details there. To us, pretty importantly, is one aspect, and that's trustworthiness. VanillaStack and the ecosystem in which you are working should always be trustworthy. So it should be open source, and you should become like 100% of open source. And you might ask yourself, where is VanillaStack able to run? Well, let's put it short, everywhere. And that is then again the point where people like Jurlind and Archis are going to look a little bit anxious. The hairs basically getting away from the heads, because if it runs everywhere, your security holes and your security issues are going to be everywhere as well. And that is basically something we want to touch upon in a few seconds. But please allow me for showcase you the Vanilla installer, because that allows us to basically pave the path for what's to become what's to be discussed next. So I'm going to change my my sharing. Again, Arch is pretty much the same as you do. It is always a problem there. So now I head over to my, I am not supposed to showcase that because that is Vanilla Manager. I'm going to showcase that one. That is VanillaStack installer. It's always a hard thing to basically turn on screen sharing. Okay, make that short. I don't want to take too much time off the clock. So VanillaStack is going to be installed and later on managed. You have seen the manager for just a very short second because it's not officially released yet, but a different thing. It is open source. That's pretty important to us. And in general, you basically have to do some decisions, but you are abstracted from all the complexity typically associated with rolling out your cloud native workload. So you need to decide whether you want to have an HA installation or not. We always recommend that because HA means high availability and high available, and is basically the basis for doing things in a production grade way. You then select your initial workloads. VanillaStack always comes with Rook as object storage. So you always have built-in object storage. Just cross that off your list because you do not need to do that on your own. It's already part of what we do. You can install OpenStack and Cloud Foundry, and then you would basically say, okay, which amount of worker node need to be provisioned first. I keep that with 3, but frankly, 3 is just a pure basis. Here's the only screen that forces you to basically leave your browser when installing VanillaStack, because you have to copy the SSH key that is generated by VanillaStack installer onto your machines, because we don't want you to enter your credentials to your machines. That would be a bad idea, or to perhaps even copy your private key onto our system. Always a bad idea. If somebody tells you differently, well, he's lying. Then and I'm just doing a dry run, so I can basically enter whatever I want to enter here, but let me enter something which might look useful. So you need to enter the IP addresses and the usernames of the users that are supposed to install the software. So I just add some more or less random values, but then we come to a pretty important point. We need to assign our workloads to our nodes because our software and our workloads need to run somewhere. Once we've done that, we execute a short node check. Well, everything is done. Everything is laid out. We have enough resources. We decide for an internal load balancer here, but we can go with an external one as well. And we basically do some cluster naming here, so that we are able to access our cluster later on. We always have Let's Encrypt built in, so I need to enter my email address to make that work for us, because the certificates are to be rolled out. We can change the Rook settings, the OpenStack settings, which are quite a lot, but they are all pre-populated with useful settings. So just look into that and then do your changes. Cloud Foundry settings, and then we can roll out additional tools. Those additional tools are tools that make your life easier, as for example, Harbor, which gives you your own container registry, which makes a lot of sense given that Docker just recently announced that there will be limitations in place in future. Prometheus Grafana for your logging, FStack for your application logging, Jaeger, Cert Manager, and Nginx, Ingress, and so on and so forth. And then, ooh, look what we have here. We end up with a screen that allows us to directly roll out Polyverse. We need, if we opt for Polyverse, we need to enter a key, and don't try that at home because it's not going to work with a key named test. That would be your individual key, which you can basically create using Polyverse's website. Just click on the link, you will be directed over there, and then you can basically register and do your purchases and ultimately roll out Polyverse. And then, yeah, finally, VanillaStack is a commercial offering, so you would need to enter your commercial credentials or just leave them blank. Then you install the community version, which is functional in regards to functionality, pretty much the same, with the one difference being it is then a rolling distribution, whereas the commercial offering is a stable one. And then summary and installation starts. And since we are just doing a dry run, I do not need to showcase that, but I just tell you, could have been done in like 45 minutes installing a complete VanillaStack. But Jurlind, I've seen you like going this way when I showcased Polyverse. So that gives us an awesome way of handing over to you. Perhaps introduce yourself pretty shortly, and then please tell us why you reacted that way when you've seen the Polyverse logo there and the option to enter your key, your Polyverse key.
Thank you, Karsten. So first I introduce myself. So my name is Jurlind Budurushi, and I'm working as head of security at Cloudical, and I'm pretty excited to have also Archis here from Polyverse, as they are doing great job, as they are going to show later. So this is then for you to understand why we love also Polyverse and Archis, because the things they are doing. Let me then try me be the third person trying to share the slide if this works a little bit better. I hope my slides are shown and can be seen. Yeah, so Karsten already pointed out a lot of times security and why security is important. And here on this picture, I just borrow this the picture and included, of course, VanillaStack where it should be. Well, these are the layers of security in cloud native. If you see this picture, it seems pretty easy, but it's a huge complexity that is behind the picture and the different layers that there are behind the picture. So you have the infrastructure layer below, then you have the VanillaStack layer where we see while Karsten was showing the architecture that it is composed of a lot of components that are very useful and they are necessary for doing everyday operations. Nevertheless, they mean that we need to think of all of them and to understand how they're working, because I would like to say and to make a statement is we shouldn't put security as something that you should be afraid of, but it's a process which is integral and continues into your working as you do all the other stuff. So it's something that you need to think about it, and it's better to think from the beginning rather than in the end when something goes wrong. So while you start thinking from the beginning, you will see that this is it's much more easier than probably it has been put out there, or people are afraid, or when you talk about security, they think some magic happens in the background. Of course, some magic it is there, talking about number theory and cryptography, but we are not going to talk about this today. But we know that what is the worst enemy of security, and we know that this is complexity. And this is exactly what that picture before was hiding very nicely, because it was only these layers and only some nice symbols, but you need to think really what is the complexity behind that, and the complexity means this is your worst enemy. Well, nonetheless, with beside the complexity, you hear statements like this. So you read statements from very well-known publishers then saying that 90% of the cloud security failures will be the customer's fault. So then you get really afraid. Then you think, okay, is cloud the way we should go? And why is this like that? So what changed actually? And in the bits and bytes, nothing has changed. So it's just a kind of shift of the thinking, is a shift of the processes and understanding how this new ecosystem is being built, and trying to do this by design, and trying to do this in depth, and integrating this into the processes. But the most problem here, or the biggest problem that I see here is the responsibility. So when we are talking, so this is where the most misunderstanding also starts when it comes to the security itself, is the misunderstanding of the models. So when we talk about the cloud, we know that we are sharing responsibility. So it's very important, and it's key to understand where my responsibility starts, what are the layers that I'm using, and what should I expect from the services I'm relying on. So what should they do actually? What should they provide to me so that I can be secure, at least in a context that is necessary for me, because I'm not going to be secure against everyone, or 100% security. It doesn't exist, because the systems are just too complex to provide that, but at least that you have done your own homework. So that's why you need a holistic approach. That is, I cannot emphasize this often enough, because this is what it looks like at the end. Most of the people building a lot of infrastructure and putting, maybe just let's call it, especially in the cloud native and ecosystem, well, we need a web application firewall, and this is it. So this is doing it. And this is what it would look like if you imagine this in a physical world. So you would have a front door, and well, the garden around it, it's open to anyone and can enter your house, and whatever you can imagine. So why, and having this picture in mind, and having this this mindset, this is what we are striving and aiming to provide with VanillaStack. So we are integrating security from the beginning by design, and providing the tools that would help you to increase the security when you using VanillaStack. So what is the roadmap that we are actually seeing? Well, you know this picture already. Karsten showed it in his slide. So this is the architecture of VanillaStack, not all the architecture, because below you have, let's say, wherever, as Karsten said, you want to install VanillaStack and you want to run VanillaStack. So this is it. So in the beginning, we want to see security 1.x, and I'll come into the why I call it an X there, because in our understanding, we have a couple of steps that we need to do there. So you cannot do everything from the beginning. So we are going step by step, layer by layer, and trying to provide you the key points in there so that you can use them and improve the security of your whole environment. And the other one would be, well, security 2.x, meaning that we also are interested not only into the VanillaStack, but would like to support you, and also with where is this running? I'm on a private cloud. I'm running this on my own data center. I'm running this in a public cloud. So there I need to think about what are the responsibilities. So now the job is a little bit, well, bigger, I mean, the responsibility, because now I need not only to think about the VanillaStack itself, but I also need to think about the layer where I'm running this, and I need to think about these responsibilities and what can I make out of it. So starting with vanilla security 1.0, meaning what is the first step? So what you get already with VanillaStack. So what is already included, and we will for sure increase that and extend that in future releases. But what you get already integrated is for logging. So you get tools, Elasticsearch, Kibana, and FluentD. So you can take the logging, log your system, and provide those loggings to, let's say, a ZM, right? Because you don't want just to collect the logs, and someone needs to interpret those logs and maybe even understand them and put some intelligence behind them and try to understand if something is going wrong in the environment. In addition to that, also monitoring. So when it comes to monitoring, it's also about, people think, okay, so what is monitoring has to do also with security? Well, think about availability as one of the goals of security. So monitoring is a key component there when you talk about availability. So you need actually to monitor the performance and the workloads on your system. So we are providing Prometheus and Grafana already, just an easy click, as Karsten showed. Well, image registry, this was also already mentioned. So why is it good to have an own image registry? Well, there is the same traditional thinking here. So while containers started in the beginning with Docker, so it was something new and people wanted to try. So they were just, and it was not something that everyone could do, building their own containers. So, and this is one of the promises of the containers, that you can replicate them and reuse them as much as you want. But imagine like you want to install whatever an application, let's say Adobe, without wanting to make any commercials here, but you didn't install that application on your machine just because you wanted, or you didn't, let's say, develop it yourself. So you installed that application on your machine, and you made sure that you downloaded it from the right source. The same is here also with the container images. You want to make sure that you are running the right containers from the right source, because otherwise, if you just install them from any source, well, you can imagine that all what you cannot imagine will happen. We provide also for some PKI, and we have the interplay here between Cert Manager and Let's Encrypt. So this is also just by even not selecting, but this is already integrated and is working by default. So you don't even need to click that, but it's set by default. Talking about images, we also have Claire, which is a part of Harbor itself, and scanning for vulnerabilities. And well, at the end, we also have a tool which helps you prevent even zero-day attacks. And this is Polyverse. So you are able, as Karsten showed it before, you are able to install and deploy Polyverse below on the nodes where the Kubernetes cluster is running. And now I would like to hand over to Archis, and he is going to show why Polyverse is doing and why is that important when it comes to security and the groundbreaking technology that is behind that.
Awesome, thank you. I'm going to share my screen now. So this is considered extreme bravery because I'm going to share my entire screen. And this is always way more fun and more exciting. So, you know, you've heard of Polyverse, and, you know, I said something about, you know, usable security and whatnot. I'm going to go into the slide deck in just a moment, but first, let's actually conduct a zero-day attack. And you can do this on your own. If you go to polyverse.com/learn, we have these online, you know, in-browser terminals where you can actually run these demos yourself. And what we've done here is I have a little Netcat-based echo server. It's really simple. And, you know, here I have a terminal. on which I can ping that server, and it just echoes back to me whatever I say, right? And what is different about this echo server is it has a buffer overflow. It's a small one, so like the boot hole buffer overflow is 8K bytes long, right? And then so after 8K bytes, you actually overflow into some space, and it's really hard to show. So we have a very constrained one. Now, what we do here though is, this is standard Alpine, but if I send it a very long string and, almost as if I'm taunting, I put an overflow and then right, and then I start injecting some code. And what this code is it's actually code that I'm injecting in the process that then, is going to give me a pingback terminal on this little terminal. And so these are all like different containers, but they can be VMs. Containers are easier, right? We're all cloud native. So when I do that, nothing happened here, right? Nothing changed that I could tell as the operator, right? So this is a 0 day. There's no hint that something's gone wrong. But let's see what happened here. And I actually have full access to that remote container. Oops. Right? And I have full access and I can do whatever I want, and I can screw up that file, and I can like, echo foobar2, right? And all my users are now gone. And, so this is how quick a 0 day happens, right? Because what happened here is it took me a very long time to make this string, right? It's hard, right? But once I make the string, even with ASLR, that string will keep working, right? So if you can ask me to prove that in the questions if you'd like, but I can restart this process 1,000 times. And so now it's moving in memory, right? And I can run that exact same attack string and it's going to work, right? Oops, I didn't open that. Yeah, you always have to, set up in the right way, but I can try that attack string and then it works again, right? And so even with ASLR, once I have this attack string, it's broken. So okay, so what do we do in this situation, right? This is a 0 day, right? This string is on no malware's dictionary yet. And this is quite literally true. It's not. You can go verify this, right? No AI has had the time to learn that this buffer input leads to an overflow, right? So you have had no time, no chance to go stop this. And the patch, you don't even know where the buffer overflow is, right? So what are you going to patch, right? How do we deal with this? I'm going to go to the slide deck real quick and go here, which is the real problem was, ASLR is great, but ASLR only moves, an entire library, and so it's one offset, right? Now, if my whole program was offsetted by the same amount and my buffer overflow is in the program, right, ASLR doesn't do much to stop it, right? And so what we do, what Polyverse fundamentally does is we take all of Linux, right? All of open source Linux, and we recompile it from scratch, right? The entire stack from bootloader all the way up to every package in every distribution. So, we call out SLES because they're a very, they're a very close partner, SUSE is, but we do every distribution on the planet. And the way we scramble it is the attacker now has complete unpredictability of where code and memory locations are. But what we don't do is we don't inject anything. So here's an example. Astute security observers will realize this is actually the victim function for Meltdown. If you ran this function on a regular program and the kernel pages were mapped in, before the patches came out, you would be able to read all of kernel memory using like a simple user mode program having this function in it. And what this does, what polymorphing does is this is an example of 3 different assembly layouts of that function. And what you notice is they're just plain assembly. there's no hooks, there's no trampolines, there's nothing there, right? So it's performant, it's equally performant. It has, similar number of instructions, similar number of bytes, right? It varies by 1 or 2 bytes here and there, but it's fundamentally the same program, just written in a different way. And if you remember CS 101, comparing two isomorphic graphs is an NP hard problem, right? So like taking these three things and then asking, what do these things do semantically is a very hard problem. So going one way is easy, going the other way is hard. And so that way we make the attacker's life like nearly impossible, right? And so now let's go back to how do we stop that thing, right? So like you saw me attack this, but how can you or I or VanillaStack stop this 0-day? Well, this is what we do. And like I said, in transparency, you see my entire screen share. So first we install Polyverse. Well, how do you install Polyverse? How do you do this magical scrambling? It's really simple. If you look at your package manager, it has these upstream repositories, right? And this is where, like, if I did apk add curl, it actually comes from one of those repos, right? That's exactly how it works. Well, let's install Polyverse. And all this, yes, it's a shell type pipe to bash right now, right? But it doesn't quite have to be that way. And then you can always cache the shell script, right? But all that this script did is, oops, why am I, oops, that was, there we go. Here, let's do that. All it did was it added Polyverse's repos as the preferred mirrors on top of the regular upstream mirrors, right? And that was the only change that as an end user, anyone had to do. And then past here, we just use our package manager like we do. And I'm going to reinstall all packages, which is this, and we already updated, and I'm going to upgrade, and so it's going to replace all my packages with polymorphic versions. And all that happened is like those assembly instructions, it's all semantically identical, but practically syntactically different. So now if we run the exact same attack again, and I'm going to open up my little netcat reverse server, and I'm going to run this, so now I'm an attacker who is, what they're doing is they figured one thing out, right? Like I'm a script kiddie, and I'm just going to all Alpine echo servers on the planet and running this one string, and it caused a seg fault. So what's notable here is not only that we stopped the 0-day, right? Without even knowing where it existed, knowing the attack string with no AI, no ML, no other security tools that had a chance to catch up, but we also caught them. And so now if I run, whoops, damn it, that happens sometimes. I didn't run this as privilege. We'll see if this one works. Yeah, no worries. But if you actually look at the kernel message log buffer, right, it was noted as a seg fault. And by looking at the seg fault, you know which process it came from, where the overflow was, and how to stop it. And so now you can even create patches. So you're not only stopping 0 days, but preventing them and fixing them upstream, which I think is very cool. So with that, I'm gonna stop and share back.
It's pretty cool.
Awesome. What I feel is so important in that whole situation to understand and to keep in mind is the thing that Jurlind said, and basically Archis demonstrated. Even if you have, and it's quite simple, imaginable that Archis would have done that on a machine that perhaps runs VanillaStack. Even if you have something like a cloud stack that is set up with security in mind, even if you have something like the most sophisticated Linux installation ever seen, it just is not enough. It simply is not enough to ensure security. The thing that is so important is, and Jurlind mentioned that, is that kind of holistic approach. Jurlind, by the way, I so much love your picture. I really, you need to hand that over. We need to share that later on. That is such a great picture because it basically nails it to the point there. So what should we take away from what I said, from what Jurlind said, from what Archis said? I start and then I hand over to all the other guys for a very short resume. And by the way, dear attendees, if you have any questions, feel free to ask them. We are here, we are the experts. No, let me be frank. Those two are the experts. Ultimately, it's your chance to ask us all the hard questions now. What I take away again is complexity is a huge problem, and complexity causes failure and security issues. That's why, shameless plug, VanillaStack takes away the complexity from you, but it cannot guarantee 100% security. That's my takeaway. Jurlind?
My takeaway is that we just saw it. We shouldn't be afraid of when we talk about security and think, okay, this is a very complex topic, so let's close our eyes in front of it. But we saw that if you know your, let's say, system networks that are running and you have the right tools for securing them, it can be pretty easy, as it was just shown in the presentation.
Archis, what is your takeaway?
Yes. Oh, I'm sorry. Yeah, my takeaway is my takeaway personally is that DevSecOps security or security should serve you, right? We are service providers. We are not ordering people, right? We're not commanders. We bring you things, and we are supposed to make you feel better, not frighten you. And that's what the two companies together are here to do.
Awesome. There's one question that I want to just throw in here for you guys to answer that, and I'm afraid that's going to be not a short answer. How is the thing and the approaches that we've shown and showcased different to, say, other kind of DevOps security tools or to DevSecOps per se? Is that related? Is that something different? Is that something, I don't know, which is a completely different track? What's your take on that, Jurlind and Archis?
I'm afraid I don't understand quite the question. So what is this towards the question? What is different to what? So I need some reference objects when I compare things. I need two sides, but maybe I'll try to say something that probably it goes on the line what was meant. So I'm just interpreting or assuming here. At least for what we were talking about, VanillaStack, we are providing the vanilla versions. So, and with that, we are also introducing to each layer security tools that are out there, integrating those that make sense or help you to address security challenges when you have such a stack, when you have these different layers. And well, with Polyverse, maybe Archis want to say something more on that and emphasize what are the differences.
I guess my I'll answer in a maybe geeky way because that's how I think. But I think the way I always think about what's different is if we assume that the hack was going to happen, right? So like if mistakes are going to happen, and I'll bring the sec in the DevSecOps. So it's my favorite story, right? In 1998, if you picked up a PC Mag, there were these big HP servers, right? And you bought one of this big server, I don't want to call out HP, but any of the big vendors. And they were these, mission critical servers, and you ran airline systems and banks on them. And the server can never go down. And then you just write code however you want to write code, right? and you just write bad code or good code, the server keeps it mission critical, right? And it failed, right? And then in 1998, Google basically started saying, no, you know what? I'm going to go to the Best Buy and I'm going to buy like whatever cheap junk they have, but my software is going to keep the service up, right? Any one server is not important. And I think that's the sec part of the DevSecOps thinking that, say, Polyverse brings in is, if we protected every binary from every buffer overflow 100% of the time, right? Then no one ever has to worry about anything, right? Or we can basically say, yeah, you know what? Once in a while, we're going to screw up, even with Rust, even with Java, even with everything, Golang, right? We're going to have one or two mistakes, and that's okay, right? So long as the overall service is secure, the organization is secure. And so we're no longer fighting for that one thing. We're overall improving posture. And I think that's the big mind shift difference between traditional tools and the DevSecOps sec.
There are two more questions that I want to bring into the game. First of all, there is a question that I received before this conversation, but I feel like it's pretty important. And you touched on it a little bit. Is Polyverse, is Claire, is Falco, is whatever we bring in as security tools truly a replacement for something like DevSecOps? Or is it basically something that works in an additional way? Does it take away my responsibility?
Sorry, no. What it does is it helps you, right? So it reduces the panic. So like, for instance, on the day boothole was patched, the next morning, a lot of machines did not boot up, right? So like, we could technically say that boothole was fixed because the machine just didn't boot up, or we could, but what Polyverse did was it gave people one more week to apply that patch. And I think what it does is it's a tool in your tool set. It's, it helps reduce risks. It's more like an insurance or an airbag. You should still drive your car better, but still have a seatbelt and have an airbag, and we will make that impact much, much better, but it's still going to be unpleasant.
It's something, Jurlind, before you answer, I have a background as developer, and I'm talking here to my two natural enemies, basically two in one, both of you. You have an operational background and a security background. That is something that literally drives me mad. But the point is, I'm just sitting here and nodding because it's exactly the way it is supposed to be, and it is to be understood from my perspective. Tools plus processes. It's not one or the other. Your Polyverse installation could be awesome, but if you are running your workloads and they are then again not secure because your processes are not working, you do not do any kind of proper threat modeling, you do not ask yourself what is going on there, where would be the loopholes, things like SQL injection, things like query string injections, whatever. You cannot take those things away using Polyverse, for example, because it's a completely different layer. And I'm going to touch on the layer in a few seconds with the next question. But it all, as Archis said, adds up to each other. It's like an airbag, it's like your seatbelt, it's like even the horn, whatever. It just adds up to each other. So Jurlind, you said the word holistic is exactly the point. But that is why it is so important to us as VanillaStack to be a partner and to work closely with Polyverse, because it does not end at the level of Kubernetes. And to Polyverse, the same is true. It does not end on a level where you basically roll out your packages. It all belongs together. It starts at the same point, it ends in the same point. That's my take on that. Jurlind?
Yes, so I really, so it's like music to my ears what I'm listening. So it's I mean, it's all what people need to think about, that picture that you really love. It makes it to the point that you need this holistic view, and you just already did again emphasize a lot on that, which I can only agree on that. What you just said, it's the way people need to think about it, with respect also to maybe relating this a little bit to the question that we have with the DevSecOps, meaning that you still need to do your homework in all of the layers. So installing all these tools, it doesn't give you security per se. However, we are providing you with an ecosystem of different tools, their combination, and configuring them the right way would provide you a pretty secure environment, which that, as Archis just put it, the impact can be less pleasant than running whatever Formula One car and with 300 kilometers without any barriers on the left and the right. So you know it's gonna end up very bad. So these are the barriers that we are putting in there, but it's still your responsibility. Yeah. Thinking about, again, that picture of understanding where are my responsibilities, what do I need to do, and how are the interplay of these tools. So this is something you still need to understand. So these tools don't have the magic stick and saying, well, everything is now a black box. This is not what we want. We want open source, we want transparency, we want to understand how all these systems are built and working together.
To me, one thing is pretty important, and it gives me the path to the next question. By the way, last chance for questions, because we need to end in a few minutes. What I feel like is pretty important is the ease of use in regards to security. So Archis a little bit apologized for how easy and simple it is to roll out Polyverse, but I feel like that's exactly the right approach. The same is true with VanillaStack. We need to take away complexity. It must be as simple as just, flipping a checkbox or just saying yes, and that's it, because it is complex in itself. So why do we tend to make it even more complex? So frankly, I feel like that is so important, and it is such a relief to see that with Polyverse and with VanillaStack, because we share exactly the same mindset there, although we are coming from different angles. So the interplay of those two things is so important, and it's so simple. And to me, that is to some extent a game changer, to be honest. Because it just makes sense. One last question, and it is a question. I'm interested how Archis is going to answer that, because it's a very, very simple question. You can answer that with basically one word, but I would hope for perhaps another answer. So Polyverse, on which layer is it working? Is it just Linux, or is it perhaps working on the Kubernetes level as well? Where is Polyverse working?
So I'll give you a detailed answer. So the way we do things, right? We look at the security posture of, we go by a histogram of all the bugs. So the first bug, the greatest bug on the planet right now, is memory safety. And so we work on every executable anywhere, right? Which means we work on the whole Linux package system. Then we work on the Kubernetes binaries themselves, right? By scrambling the Golang code. We work in Kubernetes on the containers themselves, right? When they have an OS stack and one that we can compile and build. But also we give our scrambling builders as well, which allow customers to be able to take their source code and scramble it as well, right? So basically, if you have source code, we will protect you. And there's a different answer there, which also I want to emphasize. So Linux has a lot of security tools that are built in upstream, but they're only beneficial if you can recompile your Linux from scratch with a secret key. A great example is in the Linux kernel is a struct randomizing feature. where you can change the order of the C structures inside the kernel, which prevents random rogue modules from being loaded, right? And you can only do that in a beneficial way if you can have your own key and not use an upstream distribution, right? So like we help even there, right? Just in a different dimension. And then with the polyscripting stuff that we're doing, we're also working on an interpreted language level to stop attacks like Equifax and code injection, once and for all in again that simple aspect. So that's my detailed answer.
It's an awesome answer. And since we don't have any more questions left, I would leave it like that, because those were awesome answers to awesome questions. I truly loved the presentation of the both of you. It was very, very insightful. I personally learned a lot, and I feel like our audience did so as well. So it was an hour well spent. Thank you for that. Thank the both of you for that. And thanks to our audience for watching this webinar and for watching the video later on. So stay tuned, come back, enjoy VanillaStack, enjoy Polyverse, and enjoy the ease of integration, because we just started on that, to be honest. I don't want to promise too much, but there are great things ahead in regard to the integration, in regard to security. So stay tuned, and thanks for joining in today. See you. Bye.
Thank you. Bye-bye.
Thank you for having me.